We are building the first interchain database for blockchains based on Cosmos and Ethermint technology, dTypeDB. A building block for dTypeDB is interchain transactions for both Cosmos and EVM. You can have Cosmos SDK interchain transactions with interchain accounts today, but we are proposing standards for interchain EVM transactions based on dTypeDB. And today you will see a first demo of interchain EVM transactions on our two public cutting-edge blockchains, Mythos and Logos. We are using a bridge proxy smart contract deployed on Mythos at this address to execute the same transaction data on both Mythos and Logos. The smart contract acts as a gateway for effectively replaying the transaction sent to Mythos on Logos. The underlying tech uses interchain accounts as made available by the Cosmos SDK and abstract accounts, our idea for supporting programmable transactions and smart contract generated transactions. And what you see here is a dApp that is connected through the MetaMask wallet to the Mythos blockchain. In this demo, the interchain transactions are paid by the user account. So the first thing that we need to have is a Cosmos interchain account. And this is the command to open one. And you can see my Mythos account address, the IBC connection ID, which is the connection between Mythos and Logos, kept open by a relayer, the chain ID for Mythos, and the RPC endpoint. And now we can query the interchain account created. And this is the address, and notice that it has an address for the Logos blockchain. Now we need to make sure that this address has enough tokens on the Logos chain to pay for the transactions. So we sent it some tokens, some light tokens. Now we can go to the Mythos chain and deploy a smart contract through this bridge proxy contract. And for this demo, we have a simple set and get storage contract. We copy the deployment bytecode from here and paste it in this text area and choose the Logos blockchain as the blockchain to be replayed on. We do the deployment transaction. And here I am exposing the relayer logs so we can see the packets going to and from Mythos and Logos. In the meantime, the interchain transaction to Logos is made, and if successful, the Mythos transaction is made also. And on the Mythos side, we can see this transaction on the Mythos block explorer. And the input contains the bytecode for the contract, the simple storage contract that is deployed on both chains. Now we need to determine the address of the deployed contract, and for that, we need to see what abstract account was created for us. So we want the abstract account created for our Mythos address for the Logos blockchain. And this is it. And notice that it has a nonce of 6 This means that the smart contract was deployed with a nonce of 5 on both blockchains. To see the smart contract address, we can use ethers.js with a nonce of 5. And this is the address. Now we can load the simple storage contract in Remix, and it is connected to the Mythos blockchain, which has a chain ID of 7001. And we are going to load this address, and we should expect a value of 1 when we press get. And we have a value of 1. This means the contract was deployed correctly. And now we can go on Logos, which has an ID of 7002. And load this contract. And we can also expect a value of 1. And we have it here. Now we can do another interchain transaction to change the value from 1 to 5. So we take this address and paste it here. The deploy transaction uses the same replay function in the background. We have the target smart contract, a value of 0, a gas limit of 100,000, and a call data that for this demo we are constructing manually, which calls the set function. This is the function signature for the set function that changes the value. And we will be changing it to a value of 5. Connection ID is connection 0 between Mythos and Logos, and the Logos chain ID is 7002. The signature is not implemented in this version, so we'll just put some empty bytes. The signature is part of the security mechanism that makes sure the user sending the interchain transactions is aware of the interchain transaction data and of the chains that it will be executed on, and signs on this information. And now we can replay the transaction. And now looking at the relayer, we start to see packets being sent between Mythos and Logos. And we can also see the transaction in the Mythos block explorer. Which contains the state changing transaction the state changing call data that we want to play on both chains. So now we can go back to Mythos and see the new value, and it is 5. And we can go to Logos and see the new value, and it is also 5. With EVM interchain transactions and dTypeDB, which will be shown in later demos, we are bringing data sharding to Cosmos and to Ethereum if they will support IBC. For Ethereum, we talked in previous videos about our proposal for a master shard for data that is common to all shards. Right now, Ethereum's data sharding is planned based on Layer 2 projects bridging data between shards. Cosmos now has independent chains with some data bridging through IBC controlled by the core developers of each chain. But with the Golden Gate bridge, and you have seen a simplified version of the bridge in this demo today, you can have general data bridging and sharding, and common data being mirrored on multiple chains. Polkadot also has data sharding through its relay chain. So today you have seen the first demo from dTypeDB series, the interchain contracts. This is one of the building blocks of the dTypeDB tech. Contracts are deployable remotely on another chain, and the demo uses abstract accounts for deploying and then making state-changing transactions on those deployed contracts, using the same address across chains. This demo showed transaction replay bridging between two chains, or more than two chains in future demos. Think of contracts as being containers of data. The ability to trustlessly deploy a contract on two chains, both contracts having the same address, means we have achieved the first level of data sharding between those two chains. Access to the demo dApp and support for testing the tech is available to dTypeDB interested parties.